All right, 12.6 today we're going to be doing some counting of outcomes. So when we're talking about counting outcomes, we're looking at different combinations of different items. So if I was going to have breakfast and there were 3 different beverages and there were 3 different breads, then I can figure out how many different combinations of beverage and breads I can have. Well, one way to do that is a tree diagram. So when you make a tree diagram, you take each item and you list all the different choices. So in this case, it was coffee, tea, and juice. For the bread, it's bagel, muffin, and scone. So the first thing you do, I would call this like my start. I always call that my start, and from there I branch off the first item, all the choices of the first item. So I have my 3 beverage choices, coffee, tea, and juice. From each of those 3 beverage choices, you have 3 choices of breads. So then they branch off the bread, the bagel, the muffin, and the scone. And then you kind of make a little line through here to go here, straight across, and you can see that they just give the outcome. And then when you count how many outcomes there are 9 possible outcomes. Coffee with bagel, coffee with muffin, coffee with scone. And then you go to the tea, tea bagel, tea muffin, tea scone, and then the same thing for juice, juice bagel, juice muffin, juice scone. So that's called a tree diagram, and we'll try that with things like dice and spinners. A faster way to do this would be called the fundamental counting principle. So there's a couple ways to do this. The first one is the tree diagram, which takes a while, so especially if you have a lot of options, then you probably don't want to use a tree diagram. You're going to want to use something called the fundamental counting principle. This relates the number of outcomes to the number of choices. When you know the number of outcomes, you can find the probability that an event will occur. So it says, what's the probability of randomly selecting coffee with a scone? So I know we have coffee with a scone. There's only 1 of them, and it would be out of 9 total. That's a probability. What you want out of the total possible. If you're not making the diagram, though, you're going to use the fundamental counting principle. You take the number, every amount of choices you have. So you have 1 beverage or 3 beverage choices times 3 bread choices, and you have a total number of 9 choices. If you're finding the probability of it, you can think about how many you have for each and just multiply those together. You can multiply the probabilities together. So if you know that you only have 3 beverages, coffee, tea, and juice, the chance of picking coffee is 1 out of 3 times a scone. You know that there's only 1 scone out of the 3 choices, and so that means 1 out of 9. And when I said coffee with scone up here, I said there's 1 combination like that out of 9 total combinations. All right, down at the bottom, fundamental counting principle. So fundamental counting principle is the choices for event 1 times the choices for event 2. So m choices times n choices, however many number you have. The m and the n can change. It depends on the number of choices for each event. That's all that those represent. And when you multiply that, it gives you the number of possible outcomes. So on the top I had 3 choices of bread times, or 3 choices of beverage times 3 choices of bread, and that gave me 9 possible outcomes. So if I'm trying to figure out all the different outcomes that it can happen from rolling a number cube, and when I say number cube, it's just 1 dice, 1 die, and flipping a coin. So let's say that I want to figure out the number of outcomes for a number cube, and a number cube being dice means it's numbers 1 through 6. So there are 6 choices on a number cube, and let's say I want to now flip a coin, times 2 choices on a coin, right? Heads or tails. And that means there are 12 possible outcomes that can happen. Probability is the number of favorable outcomes over the number of possible outcomes. So that's basically what I want to happen over the total. Right? So let's go back to that number cube. And let's say I want to know what the probability of rolling a 3 is. Well, you have to think about how many 3s there are on the, how many of what you want. There's only 1 3 on the number cube out of 6 total. What if I want to know the probability of rolling an even number? Well, on a die, the even number are 2, 4, and 6. So there are 3 even numbers out of 6 total. And for probabilities, you will always reduce. So the probability of doing that is 1/2. Okay. Before we do some other examples on here, there's a lot of card examples, so I want to make sure I go over the deck of cards so that you know how many cards are in a deck and how many of each suit, in case you're not familiar with it. So if I take a deck of playing cards, there are 52 cards in a deck. Okay? It has 2 colors, red and black. You just split it in half. There's 26 red, 26 black. From the red, you have hearts and you have diamonds. Hearts and diamonds, there's equal amounts of each, so you split that 26. That means there's 13 hearts and 13 diamonds. And for the black ones, I can't draw spades and clubs, I'm terrible. Spades are 13 and clubs are 13. Okay? So we know how many there are of each. All right? It says find the number of possible outcomes for each situation. So when you're finding the number of possible outcomes, you have to multiply the choices. Multiply choices. When you're finding possible outcomes, you multiply the choices. So I have one 6-sided number cube is rolled. 1 card is drawn from a 52 card deck. So on a number cube, the number of choices are 6. So I'm going to put the choices underneath. And the number of choices from a deck of cards is 52. When you multiply that together, you get 312 outcomes. You would never make a counting tree for something like that. There are 512 juniors, 498 seniors. 1 junior and 1 senior are randomly drawn as raffle winners. So I want to know all the different possible outcomes. So I have to take the number of choices, 512 juniors, times the number of choices, 498 seniors, multiply that together, I get 254,976 different outcomes of picking a junior and a senior. That's a lot of outcomes. Next, we're doing a probability. Probability you're going to do in fraction form. And you're always going to reduce. So a coin is tossed and a card is drawn. What is the probability of getting tails and a 10 of diamonds? So to write probability, you'll see it written like this, with a P and then a parenthesis with what you want. So T for tails and 10 of diamonds. Okay? So on a coin, what you want is tails. There is only 1 tail out of 2 total choices. Okay? In a deck of cards, there is only 1 10 of diamonds out of 52 choices. So the probability of both of those things happening, you would multiply together, and you would get 1 out of 104. Probability of flipping heads and getting any diamond. Okay, well, flipping heads, there's only 1 out of the 2 choices. And then getting a diamond. Up here, there are 13 diamonds possible in a deck of cards out of 52. So I get 13 over 104. I'm going to show you how to easily reduce on my calculator. If you put in 13 divided by 104, you hit the math button and then enter twice. Excuse me. You can see that it reduces it for you to 1/8 because we want to always have our reduced answers. 4 coins are tossed. What's the probability of getting 4 tails? Okay, probability of getting 4 tails means each time you're going to get tails and you're going to multiply all those possibilities together, or all those probabilities together. So the first time, the first coin has a 1/2 chance of getting tails, so does the second, so does the third, and so does the fourth. But to get all 4, you would have to multiply all those probabilities together, and it would be a much harder thing to do, 1/16. Possible outcomes. This means we're going to multiply. We want for a 5-digit number. So let's think you're playing the lottery, and they all have these boxes with the little balls bouncing around, and let's say they all have the digits 0 through 9 in them. They all have single-digit numbers in them, so every box has 0 through 9. So you have to think about that. It's not 9 digits in that box, it's actually 10. 0 through 9 would be 10 possible digits. So it's a 5-digit number. That means there's 5 items here that have 10 choices in a box. The digits 0 through 9 have 10 digits in them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 10 choices. When you multiply those together, you have 100,000 possible outcomes. So think about those lottery choices where they have numbers that go up to like 60 some numbers. So the choices for those getting picked is going to be even higher. Okay, we're going to practice making a tree, because you're going to have to do one of those with 2 coins. And then on your homework, I think there's one with 3 coins. So if I'm going to do 2 coins, I'm going to start with coin number 1. Coin number 1 has possible choices of heads or tails, and I'm just going to use H and T for my heads and tails. From that, I then flip coin number 2. So off of this one, let's say I flip heads the first time, the next coin could get heads or it could get tails. So you could do heads with heads or heads with tails. So if you're on your homework and you have a 3rd coin, you would make another branch and then you would go 3 letters at a time. This one, so you'll be able to start your one on the homework that looks just like this. You could flip tails the first time, and then the second coin could be heads, which would mean you would then have tails and heads, or you could have tails with tails. And so the last one are all the different outcomes. They're very specific. When you multiply them, you can see how many total outcomes, but when you make the tree, you can see the individual outcomes that you would have. Okay? Let's find a blank page in your notes. Let's make a spinner. 1, 2, 3, 4, 5, 6, 7, 8. With 8 parts. So you can pause this if you need to pause it to make your spinner. We're going to do the probability of not a 7 or an 8. So you have to count how many are not a 7 or an 8. 1, 2, 3, 4, 5, 6 of them. Oh wait, I'm doing odds. Sorry. Probability of not a 7 or an 8. 1, 2, 3, 4, 5, 6 out of 8 total would be 3/4. Okay? So you can do different things with a spinner as well. All right? We can do on the spinner probability of even. So probability of even would be 1, 2, 3, 4 out of 8 possibilities, and that would be 1/2. They could do things like probability of a less than 4. When it says less than 4, that means 4 is not included. So 1, 2, 3 of them are less than 4 out of 8. Okay? So there's just some other things to expect.